This is Math 414, video Math 414. We're going to talk about proper and improper fractions today, and then a few other items as well. All the fractions we've dealt with so far have looked similar to this. We can have larger numbers. But what do you notice about all of these fractions? These are called proper fractions. If you notice, the top number is smaller than the larger number in all of these. The numerator is always smaller than the denominator, and that means it's a proper fraction. So today we're going to deal with improper fractions, which means that the numerator is larger than the denominator. If the numerator, the top number, is bigger than the bottom number, that's considered an improper fraction. Okay, so we're going to talk about what that means today and how we can switch those around. But first of all, just to understand what it means if we have 3 over 2. You could even call it 3 halves. Remember, if we got a 1 on the bottom or a 2 on the bottom, we call it 1 half. But anyway, so we got 3 here, we got 3 halves, or 3 over 2. Well, we can write that as a division problem. That's actually a division problem. You could drop your 3, the way I like to think about this, what I'm going to use, drop the 3 into the box, and then bring the 2 down. So that way you've got it straight. Well, what number goes in the box? Well, the top number goes in the box. Because the way you would read this 3 divided by 2. So this is 3 divided by 2. Okay, so 2 would go into 3 one time. 1 times 2 is 2. We would subtract and we'd have 1 left. Now remember that 1, we could call that remainder 1, R1 for remainder 1, or we could write this as a 1 over 2. We got the 1 on top over the 2. So that would be 1 1/2. So let's look at this example a little bit more here. So 3 halves, or 3 over 2. If I have 2 of something, let's go back to our pies again here. So there's our 2 pies. We have 2 pies. If I cut these 2 pies in half, and I want 3 halves. Well, I want this. I'm going to shade in that as 1 half. This is a half right here. And then I want another half, so I'm going to color in this half. So let's say I've taken those pies and I've eaten those 3 halves of the pie. Well, that leaves this half over here. But what do we have? We've got 3 halves. This is a half. This is a half. This is half of a pie there. This is half of a pie there. Actually, it's probably better just to draw it this way here. That's half a pie. This is half of a pie. This is half of a pie, and this is half of a pie. Okay? So we have 2 whole pies. That's 2 pies, but we've colored in 3 of the halves. So that's what we have. That's what it is 3. When you say 3 halves, you'd have to have, you see the 2 full ones there at the bottom, but we've got 3 halves there. So that's what that means. Now, like I said, you can write this as a division problem. Drop the 3 down in the box, divided by 2. You could also, do this a couple different ways like that. But let's show division. Let's go back to a proper fraction. Let's go 2 divided by 4. 2 fours, that's the same as 1 half. But let's just say if we wanted to do that, we'd have the 2 and we put the divided by 4. We can also write 2 divided by 4, or we could write 2 divided by 4. This fraction bar is also considered another way of writing division. So either one of those would give you the same answer. If I worked this out, this would all give you three answers, would all 3 be the same. It's just different ways of writing division. So let's go back to a improper fraction and see how we can change that to a proper fraction. So let's go to 5 over 4. That is an improper fraction because the top number is larger than the bottom number. So we're going to put that into a division problem. We're going to drop the 5 into the box, bring the 4 down, and so we've got 5 divided by 4. 4 will go into 5 one time. 1 times 4 is 4. We're going to subtract. We've got 1 left. There's nothing else to bring down, so that's our remainder. But instead of writing remainder 4, we're going to bring, remainder 1, we're going to bring our 1 up here, and we're going to put this 4 underneath it, and it's going to be 1 1/4. So let's do a couple more like that. If I go 7 over, we'll use 5 again. I'm going to bring the 7 down here. I'm going to divide it by 5. 5 will go into 7 1 times 5 is 5. I'm going to subtract. It's going to give me 2. That's my remainder. But instead of putting remainder 2, I'm going to put 1 2/5. Okay. Now, another way you can look at these, if they're easy numbers, like that we're dealing with here mostly, I could go 7/6. Well, then I would think 6 will go into 7 how many times? 6 will go into 7 one time, but how many would be left over? If 6 goes into 7 one time, I know that the remainder, there's going to be 1 left over because that's a 7 and that's a 6. So if there's 1 left over, I can just think 1/6. Okay, now I was able to do that in my head, and the more that you do these, and the better you know your multiplication tables, the more you'll be able to do it in your head to save you some steps. But just to check it here, if I put my 7 in my box, I bring my 6 outside the box, 6 will go in 7 1 times 6 is 6. I subtract, it leaves me 1. Well, there's my 1, I put my 1 over the 6, 1 1/6. That's how you would write it as a mixed number. That's how you would write a proper fraction, an improper fraction as a mixed number. So 7/6 is the same as 1 1/6. Let's just do 1 or 2 more like that. Let's go with 16 over, let's do 16 over 12. I want to show you something here because after we do these, we still need to see if the fractions will reduce. So I'm going to bring my 16 down here in the box, bring my 12, it's 16 divided by 12. You just read it from top to bottom, 16 divided by 12. Well, we're putting our 16 here, we put our division box, we're dividing this number by the number out here. So 12 will go into 16 1 times 12 is 12. I'm going to subtract, and that's going to be 4. Okay? There's nothing to bring down, so that's my remainder. But instead of putting remainder 4, I'm going to put 4 over 12. 1 4/12. So that's my answer, but can that fraction be reduced? It can. They're both even numbers, so we know 2 will go into both of those evenly. But if we found our greatest common factor, we would find out that actually 4 will go into both of those, because the factors of 4 are 1, 2, and 4, and the factors of 12 would be 1, 2, 3, 4, 6, and 12. Remember that 1 times 12 is 12. 2 times 6 is 12, and 3 times 4 is 12. So all of those are factors of 12. All of those numbers will go into 12 evenly. 1 times 4 is 4, and 2 times itself. 2 times 2 is 4. So those are the factors of 4. Well, what's my greatest common factor? My greatest common factor is 4. So this is just a quick little review on greatest common factor. So I've got 4/12 here. I've got 1 4/12. I don't have to do anything with the 1. It's fine. The 4/12 I want to reduce. I'll divide the top by 4 and the bottom by 4 to give me 1/3. 4 divided by 4 is 1. 12 divided by 4 is 3. Make sure I bring my 1 over, and the answer is 1 1/3. So 16 over 12 is the same as 1 1/3. Okay, so let's do one more like that. Sometimes you could have something like this even. Okay, so what if we have 15/5? So we got 15 over 5. Well, let's divide that. You should be able to look at that real easily and know the answer to that. You should know that, well, 5 goes into 15 3 times. Well, how many's left over? Well, none, because 3 times 5 is 15. But if you need to write it out, you write your 15 down in the box, you draw your division box, 5 will go into 15 3 times, 3 times 5 is 15, you subtract, you've got 0. So if this number goes evenly into this number, then you're just going to have a whole number here. You're not going to have any fractions with it. So those are the same numbers there. 5/15 is 3. So let's try one more where we may have to reduce something again. Let's go maybe 15 over 9. Let's try that one. So I know 9 will go into 15 one time. If 9 goes into 15 one time, there's 6 left over. So that would be 6 ninths. But let's draw it out in our fraction box here. We got our 15 divided by 9. 9 will go into 15 1 times 9 is 9. When you subtract, you end up with 6. You know, if I wanted to show all the steps, I'd make that a 15. I could borrow from that, you know, so that would be 6. There's nothing to bring down, so that's my remainder. So I'm going to put this number over the 9, which is my denominator, so 6 ninths. Okay, so I've got 1 and 6 ninths, but now I'm going to look, will my 6 nines reduce? Well, yes, I know that 3 will go into 6 and 3 will go into 9. So 6 divided by 3 would be 2, and 9 divided by 3 would be 3. So you would divide each of those by 3 to get 2/3, bring your 1 over, and 15 ninths is the same as 1 and 2/3. And that's how you change improper fractions into proper fractions, is just by dividing them that way. One more exercise and then we'll move on here. Let's try 12 over 10. So we have 12 over 10. You could reduce that first, but it's really, I think, best just to go ahead and change it to a proper form and then worry about reducing it. So I'll bring my 12 down, I'll divide the 12 by the 10. 10 will go into 12 one time. 1 times 10 is 10. I subtract and I end up with 2. So that's my remainder. So I'm going to put 1 and 2 tenths. Now before I stop, I need to always look and see, will that 2 tenths reduce? And it will. 2 will go into 2 one time, and 2 will go into 10 5 times. And I'll bring my 1 up to 1 and 1/5. So 12 tenths would reduce to 1 and 1/5. So that is proper and improper fractions and how to change them around.